Students, welcome to Sourav Sir's classes. The question is, the function fxy is equal to 3x squared plus y squared minus 2 x cube minus y cube plus 6xy has option A a point of maxima, option B a point of minima, option C a saddle point, and option D no saddle point. Now, we have been given the function fxy. Now fx, that is the first derivative of f with respect to x, is equal to 6x minus 6x squared plus 6y. Now for this to be 0, we can have x is equal to 0 and y is equal to 0, or x is equal to 1 and y is equal to 0. And fxx, that is del 2f del x2, is equal to 6 minus 12x. And fy, that is del f del y, is equal to 6y plus 6y squared plus 6x. Now for fy to be equal to 0, we can have x is equal to 0, y is equal to minus 1, or x is equal to 0 and y is equal to 0. And fyy, that is del 2f del y2, is equal to 6 plus 12y. Now let us calculate the value of fxx fyy minus fxy whole squared. For this we would also be needing fxy. Now fxy is equal to del f del 2f del x del y, which comes out to be 6. So now the value of fxx fyy minus fxy squared is equal to 6 minus 12x into 6 plus 12y minus 36. So this is 36 plus 72y minus 72x minus 144xy minus 36. So this simplifies to y minus x minus 2xy. Now, if we check at x is equal to 0 and y is equal to minus 1, this comes out to be minus 1, which is less than 0. Thus 0 comma minus 1 is a saddle point. So the correct option is option C. And also at x is equal to 0, rather x is equal to 1 and y is equal to 0, we get fxx fyy minus fxy squared is equal to 0 minus 1 minus 2 1 into 0, which is minus 1. So since this is again less than 0, 1 comma 0 is also a saddle point. And at the other points, that is 0 comma 0, the value of fxx fyy minus fxy squared at 0 comma 0 is equal to 0, so no conclusion can be drawn. So we have two saddle points, so the function has a saddle point.